Gets it to Bryant. Bryant dribbling. Has to put it up with the buzzer. Banks it in! He banks in the three! And the Lakers win the game!
Are you excited? Because I'm super excited about this section. We're talking about basketball. So we're going to have a very interesting challenge. We will be analyzing the trends of the top 10 NBA players. We want to see their trends in performance. We want to see when they've been playing well, when their stats dropped, and more importantly, we'll try to understand why. We will try to see where they've had injuries, where they haven't been playing, and what's the reason for that. And all of this is going to be happening inside R, and at the same time, we're going to be learning a lot. In this section, we're going to learn about matrices. So matrices is a way to represent tables in R. It's just one of the ways. And also matrices is our stepping stone to the next section, which will be on data frame. So very exciting challenge ahead. I can't wait to get started. Let's jump straight into it. Hello and welcome to the fourth section of the R programming course. Are you pumped? Because I am super pumped. I'm super excited about this section. I have prepared an awesome data set for you guys, and we're going to learn a lot about R while performing a very exciting challenge. Okay, basketball trends. Project brief. What do we have here? Well, first of all, for those of you who don't know what the NBA is, I understand a lot of you guys know what the NBA is, but still we have students from all over the world. So the NBA is the National Basketball Association in America, and that is the main basketball league, and most of the players that you've heard of, like Michael Jordan, they play and played in the NBA. So we're going to be analyzing the NBA players. All right, what are we going to do here? Well, we're going to take the top 10 paid players right now. There they are on your screen, the highest paid players of the 2015-2016 season, and there they are, their salaries. This is all publicly available information, and we're going to take all of these 10 players and we're going to analyze how have they been playing over the past 10 years. Imagine that. We're going to take data for the past 10 years and we're going to look at how they've been playing in those years. So your goal for this challenge is to simply investigate trends and patterns that you see in their performance over the past 10 years, because ultimately they haven't always been the top 10 players, right? Let's see how they got there. Let's see how they have been improving and what's been changing about their game and so on. And don't worry if you don't know anything about basketball. I was in a very similar situation, but you will literally understand everything as we go through. I will make sure to cover off all of the basic knowledge that we'll need, and we will have heaps of fun. So let's quickly have a look at the stats that we'll be analyzing. Here we've got stats for one of the players, and basketball fans, can you guess who this player is? And here you can see this player's stats for his full professional career, and what I have outlined in red are the stats that we'll be looking at. Alright, so going from left to right, here we've got the years that we'll be looking at. 2005, 2006 is the first season, and 2014-15 is the final season we'll be looking at. Why aren't we looking at the current 2015-16 season? Well, that is because at the time of making this video, this season isn't yet finished. So I didn't want to look at data that's for an incomplete season. If you're a hardcore basketball fan and you want to have the most up-to-date data, and when you're watching this video, the season is finished, then feel free, after we finish this section, you can go back and just modify the data, and by then you will know how to do that, and then you can just re-update it and perform the same analysis or whatever analysis you may wish to with the new data. It's all possible. After this section, you will know how to do it. All right, so then we'll be looking at this column. This is the total games played by this player in each of those seasons. Then here we've got MPG, which stands for minutes per game. And we won't be looking at minutes per game. That's one of the tables that we'll derive. We'll actually have an input table of the total minutes that player played in that whole season. And then here we've got FG percentage. I know this all looks complicated, but it really isn't. So FG stands for field goal. So how many basketballs did that person throw into the hoop during the game? So not when they get penalties, but actually while they're playing. So either 2 points or 3 points. How many what is the accuracy of that player. Once again, we won't be looking at this exact table. This is one of the tables we'll derive, and that is part of our challenge. We will have a table on the actual number of field goals, and we will have a table on the number of field goal attempts. So basically, if you divide one number by the other, then you'll get this percentage. And finally here we've got the points per game. Once again, this is the number of points that a player has scored in that whole season per game, but we will have a table of the total number of points the person has scored in that season. So there we go. We'll have lots of input data. You will see there's going to be quite a lot of it. It's going to be enormous compared to what we've seen before, but nevertheless we'll power through it. And this is one of the beauties of this section of the course. Now we're ready to jump into the world of R and analysis and data, because we've done all the foundations of programming, fundamentals of R, and now is the time for the fun stuff. Okay, so this is what we're doing. Where do you get the data? Well, let me show you. If you go to as previously, you go to www.superdatascience.com/R course. Right, so if you go to this website, as we did in the previous sections, and you go scroll down to section 4 matrices, then the data set is this second file over here. So the first file is the challenge, that is that presentation that we just looked at, and the basketball data set, that's what we're going to be using throughout the course. Then these will come later when we're finishing this section. Okay, so once you've downloaded this file, let me show you what it looks like inside. This is what it'll look like inside. And to get here, what you need to do is, once you've downloaded it, you need to unzip the file. And what you will see is, first, this will be the zip file that you download. Once you unzip it, it'll be just a basketball s4-basketball data.r file. So just open it, just like the way I just did. So, open a file from RStudio and open this file. And once you have the file, this is what it will look like. So I've got some comments. I wrote you a little comment over here. Welcome to the world of basketball data. I'm sure you will enjoy this section of the R programming course, and I am sure you will enjoy it. So here you've got some instructions for the data set, but I won't bore you by reading all of this. I'll just tell you what you have to do. All you have to do is, once you have got this file, just click Control A if you're on a Windows machine, or Command A if you're on a Mac, and select everything. Basically select all of the lines. There's lots and lots of lines here. You see, like we're not going to go through them right now, what's going on, but we're just going to execute them. So just run these lines, Command Enter or Control Enter, and once you've run these lines, what you will see is you will get the data. So basically this script is used to supply you with the data. That's because we haven't yet studied how to import data from files and so on, and it's a bit early for us. That'll come later in the course, but don't worry, we'll get there. But for now, this is just the easiest way for us to get the data into our environment. So once you have the data, there we go, it's all populated. I know this might look like a lot, and it might look a bit overwhelming at first, but don't worry, that's what data science is about. There'll be lots and lots of data, and our goal is to learn how to manage it and how to analyze it, right? So let's go to a new file, because once we've loaded this data, we don't really have to continue in that script, right? And that's the beauty of RStudio, that this data has been loaded into the environment and we can use it in a brand new script. So in order not to play around with this script, let's just create a new one, and we will start our section here. So we're not going to do any programming in this tutorial per se. This tutorial was just to show you the data, but what I did want to show you is just an example of one of the elements of data that we have. So let's say we want to look at the salaries. We've already seen the salaries. Let's say we want to look at the salaries. We see that there's an object here called salary. So if we just type in salary, as we know, and run this, what we will get, let me just make some more space here because this is a big object. And there we go, it fits. So what we'll get is the salaries of these players. So here are the top 10 players that are the top 10 now. Once again, they haven't always been the top 10, but we want to see how they have been progressing throughout their careers in the past 10 years. So the players that are top 10 paid players right now, we have a table on all of their salaries. So what their salary was back in 2005, 6, 7, and all the way up to 2014. Now, what you might say is that, Kirill, we haven't learned how to deal with tables yet. And in fact, this table has a name, it's a matrix. And that's correct, we don't know how to deal with matrices yet. We know how to deal with vectors, but not matrices. And that's exactly what we will attend to in the next tutorial. We will talk about matrices and we will learn everything about them. And we will learn how to build matrices, and that is the goal of this section, to learn how to operate with matrices. So that's kind of like a step up from a vector. And on that note, let's finish this tutorial. Go ahead and load the data into your machines, and I will see you on the next tutorial. And until then, happy coding. Hello and welcome back to the course on R programming. And today we're talking about matrices. And you're probably wondering, Kirill, why are matrices so important that we have to devote a whole section of the course to this topic? Well, the answer to this question was actually in the previous tutorial. As you could see, even the data for basketball players' careers is presented to us in table format, and in R, tables are stored in matrices. And that is how the world's data is most of the time. It's stored in table format, and if we want to know how to work with it, and inevitably we will need to because we're data scientists or data analysts, and so if we want to know how to operate with tables, we will need to know how matrices are structured in R and how they operate. And moreover, as you will see from further down in the course, there's another type of object which is called a data frame. So matrices are also a stepping stone in order to get to data frames. So let's dive straight into it. So what do we know so far? So far we know how to work with vectors. Here's an example of a 5-element numeric vector. A vector has one dimension. Now, what happens if we actually want to work with tables? And as we know, tables have 2 dimensions. They have the number of columns and they also have rows. So how do we operate tables in R? Well, here's an example of a table that has 5 columns and 3 rows. Let's start by saying that there's some data in this table. Let's say there's this number 50 replicated across the whole table. Now, obviously, in order to work with a table, we're going to have to somehow recognize the second dimension, and that's why there's another set of indexation over here. So we've got 1, 2, 3, 4, 5 on the top and 1, 2, 3 on the left. And so that's what a matrix looks like in R. So basically, it's just a table. Now, because we have this second set of indices, we're inevitably going to run into a problem. And what's this problem? Well, let's say we have this matrix, and let's say it has a name, it's called A. And let's say we want to somehow get to this number 0 in the matrix. Inevitably, we're going to run into a problem if we're going to try to use the methods for indexation that we know for vectors. Let's have a look. Let's try calling out this number 0 using the methods that we know for vectors. Let's say we will call it using A4. But that's incorrect, right? Because if you call it using A4, then there's actually 3 elements in the 4th column. So how will R know which one exactly you want? So that's not going to work. Let's try a different approach. Let's say A3. But now, how is R going to know, do you mean the 3rd row or do you mean the 3rd column? And if you mean either, then which element do you actually mean in one of these? So that's also not going to work for us. So the way you index a matrix in R is you put 2 numbers in the square brackets separated by a comma. The first number will mean the row that you want to look up. So in this case, it'll be the 3rd row. And the second number will mean the column that you want to look at. And that will mean the 4th column in this case. And wherever these 2 cross, so in this case over here at the number 0, that's exactly the element that will be returned. So that is how you index an element inside a matrix. Okay, so that's our indexation. And this new method of indexation is actually going to bring some new concepts into what we know. So you see these indices on the left here? Well, in R, they're actually represented in a different way. Instead of just 1, 2, 3, what we're going to have is 1 in square brackets with a comma, 2 in square brackets with a comma, and 3 in square brackets with a comma. So what does that mean and why is that there? Well, basically it's the same 1, 2, 3, but it's just in line with what we now know. And why is that? Well, that is because if you put the letter A in front of any one of these, so let's say A1, A2, or A3, what you will get is the corresponding full row. So for instance, A1 1 comma nothing, because here A34 meant the crossing of the third row and the fourth column. But if you say A1 comma nothing, you mean just the first row, not crossing any of the columns. So basically in R, that is a way to take this whole row out of the matrix. There we go. So that's A1 comma nothing. And same thing goes for the top indices over here. Now that we know how to index inside a matrix, their representation is actually going to be different. So instead of 1, 2, 3, 4, 5, we're going to have brackets, comma 1, brackets, comma 2, brackets, comma 3, brackets, comma 4, brackets, comma 5. Because we know that the second element inside these brackets means the number of the column. And that is basically the same 1, 2, 3, 4, 5, but it's just reminding you that if you want to select any one of these given rows, like let's say, for instance, you want to select the 5th row, all you have to do is say A, brackets, nothing, so you don't even have to put a space here, then comma 5, and then brackets close. In that case, you will select exactly the 5th row. So that is how indexation in matrices works. Now here we're running a bit ahead of ourselves. This relates to the topic of subsetting, and we'll talk about subsetting further down the track. But I just wanted to explain to you why exactly these matrices have a bit of a different style in representing their indices. And that's exactly why. It's because that's how you index a matrix, or how you get inside a matrix, and they're just basically reflecting that exact concept. Okay, so that's nearly all on matrices. The last thing you need to know about them is that in R, a matrix can only have elements of the exact same type. So just like a vector, you cannot put into a matrix elements of different types. So you can't put a character and a number, for instance, into one matrix. If you try to do that, then all numbers will be converted into characters, just like we saw with vectors. So that's one of the core principles of matrices. And now you know how they're structured and how to also index them. And I look forward to seeing you in the next tutorial. Until then, happy coding! Hello and welcome back to the course on R programming. And today we're going to talk about ways to build a matrix. So here I've got where we left off in the previous tutorial where we looked at RStudio, and we've got the salary table, or the salary matrix, now that we know they're matrices, the salary matrix for the top players. So let's have a look, and let's have a look around. Let's look at another one. Let's see what else do we have. We've got another one called games. So let's look at that. So here you've got the games that these same players played. Yeah. And let's look at another one. We've got quite a few, but we won't look at all of them right now. Let's look at minutes played, right? So here you've got the number of minutes each one of these players played in these years, right? You can see Derrick Rose was off for the whole season here with a knee injury. Anyway, so it's a bit curious, right? How are these tables created? Let's go have a look at the data. Let's go look at the script actually that we were supplied with, and let's see how these tables came to be. So comments, 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 and then we've got a vector with seasons, right? We've got a vector with players, which both of them we still have here. So there's the players, there's the seasons vector, and the players just has the names of the players, and seasons has the names of the seasons in numbers. So basically, the seasons as characters rather than numbers. And then we've got some more vectors which are no longer here. Interesting. Where did they go? Okay, let's have a look. We've got the salary. So for each one of the players, we've got what looks like their salaries in one vector, right? Instead of right away in the table, it's in one vector. And it looks like it starts from low to high. So this was his salary in 2005, and this is Kobe Bryant's salary in 2014. Okay, and that's the same thing for every player. All right, and then how is the matrix constructed? All right, salary is, so the matrix that we call, so if I run this, just the highlighted bit, that's exactly what we were looking at, the salaries matrix. The salary matrix is the result of a function called rbind, and rbind is applied to all of these vectors: Kobe, Bryant salary, Joe Johnson, LeBron James, and so on. So these vectors are somehow being put into this matrix by this rbind function. Interesting. Well, let's take note of that. And then what happens? And then we've got rm. So what does rm do? Rm basically is a function to remove. So instead of clicking this button here to remove objects from your workspace to clear it up, you can actually remove them one by one using this function rm. So if you type in rm and then an object or a comma object and like lots of objects separated by commas, you can remove them like that. So basically rm is cleaning up these vectors. That's why we don't see them. That makes sense. If we have the matrix, we don't really need the vectors anymore. And then what do we have? And then we have call names, salary, seasons, and row names, salary, players. So apparently these two vectors are being used to label the column names and the row names. Interesting. Okay, so that's an interesting start to this tutorial. We're kind of working backwards. We can see how these functions were used to create this matrix, and these vectors as well were used in this creation, but we don't actually know how all of it works. Well, now that we've seen it, let's go and talk about some of this theory. I'll show you how these functions work, and then we'll come back and we'll practice some of those on our own. I think that'll be an interesting approach to this tutorial. All right, let's get started. We're talking about building your first matrix. All right, so here's the deal. How do we build a matrix? We have the data. How do we put it in a matrix in R? Well, the first way to do it is use the matrix function. Now, we didn't see an example of that in the data set or in the script we were looking at just now, and that's because you won't be using the matrix function that often. What it does is it takes a vector and it bends it into, like literally bends it into a matrix. So let's say I have a vector of letters from A, B, C, D, E, and so on, and I have 15 letters in there. So if I try to populate this matrix, you can see it's being bent. It's like first 3 letters go here. So this is how it works. So I had a long vector of 15 elements, and then it's like put the first 3 in here, then bend it, put it in here, bend it, put it in here, bend it. It's like a snake, and it will always populate starting with the first column. It'll populate the column, then it'll go to the second column, and so on, unless you specify, and we'll see this, unless you specify a parameter which will tell it to bend the vector like that. And the reason why this function is not that often used is because how often are you required to take a vector and put it into a matrix? Usually matrices arise in different ways. Either you get it from a file or you use one of these functions. The second way is to use a function called rbind, and that's exactly what we saw in that script that we were looking at just now. And the rbind function, what it does is, as you just saw, it just binds these vectors. Let's do that again. That was pretty cool animation. All right, boom, 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 right? So rbind takes a vector. They have to be of the same length, of course. Otherwise, you can't create a matrix if they're not of the same length. But basically, rbind takes the first vector and attaches a second below it, third vector, and so on, and creates a matrix like that. And the next function is cbind. Can you guess what it does? Exactly. Cbind connects columns into a vector. So if you have 5 columns of length 3 in this case, so bam, bam, bam. So first, second, third, fourth, fifth. And there we go. So that's the 3 main ways of creating matrices. Of course, you can get one from a file, and we'll explore importing data further down in the course. But if you want to create a matrix in your script, then these are the 3 main ones. All right, so let's go practice some of these things. All right, so what do we have? We've got salary games. We don't need any of that anymore. Let's try to create our own matrix, right? So first we're going to learn how to use the matrix function. Even though we're not going to be using it that much, let's still learn how to use it. So if I run question mark matrix, what we will see is that matrix requires some parameters. The first parameter is data, and by default is NA because there is no data there at the moment, and we need to pass it. Basically, it's asking for a vector of values that will be turned into a matrix. Then it's asking for the number of rows and the number of columns to be passed. So you basically tell matrix, the function, what kind of matrix you want to build, how many rows, how many columns. And then you've got this last parameter. It tells the function whether you want to populate your matrix by rows or by columns. By default, as you can see, is false. So that means that you want to populate by rows. Okay, so moving back here, let's go ahead and get some data first. My data is 1 to 20. And so my data, if I run that, I've got a vector of 20 numbers. Now, if I want to put that vector into a matrix, I can bend it into a matrix using the matrix function. My data, I'm passing the data to the function, then I want to call the number, give it the number 4. So you can see here, pass the data, then the number of rows that you want. I want 4 rows, and then the number of columns that you want. I want 5 columns in my matrix. So it's important that these two, if you multiply them, they equal to the length of the vector, because that's the vector has to fit into the matrix basically. So if I run that and I call A, then you'll see I've got a matrix here, and it's been populated like we saw in the tutorial, right? In the presentation, it's going 1, 2, 3, 4, then it's been bent like that, 5, 6, 7, 8. So it's been populated like a snake, going up and down, up and down. All right, so that is our matrix. And as you can see here, the indices are just as we discussed in the previous tutorial. So it's not just 1, 2, 3, 4, but it's actually 1 square brackets, comma nothing, 2 inside square brackets, comma nothing, and so on. And for the columns, it's the opposite way around. So that's just how R represents its indices. And it's also telling you that if you want to get this whole row, you just put A in front of any one of these, and you just type that out. Or if you want to get the whole column, A and then square brackets, comma 3, that'll give you this whole column. So for instance, let's do an exercise. How do we get to number 10? Can you get to the number 10 using indices? Yes, we can. We just say A, 2, and 3. As you can see, it becomes a no-brainer. All you have to do is look here. Okay, it's in the second row. That tells you that it's in the second row. And this tells you that it's in the third column. And run that, you get the number 10. Beautiful. Okay, so let's create another matrix, but this time we'll do the same exact thing. So we'll copy that, but at the end we'll say by row equals true. So you can just put the letter T or type in the whole word, it's up to you. And the important thing to note here is that we're not creating a different type of matrix. The matrix is still going to be a 4 by 5. So it's not that we're going to create a 5 by 4 matrix. It's going to have 4 rows, 5 columns, just like this one. The data is going to be the same. It's just that the data is going to be populated into the matrix differently. Let's have a look. So if we run that, you will see that the data goes 1, 2, 3, 4, and then bends this way. 6, 7, 8, 9, 10, bends. 11, 12, 13, 14, 15, bends over here. So it's like a snake going left to right this time, right? So that is what we created using the same function, but with a different by row parameter. And here's a challenge for you. If you pause this video, try to get to the number 10 in this matrix now. Can you do it? I'm sure you can. So to get to the number 10, it's in a different position now. You need to take the second row and the 5th column. So let's try that. B, second, 5th. As you can see, number 10. All right, beautiful. The other function we wanted to discuss is the rbind function. Now I'm not going to bring up the help for rbind because it's a very simple function, and as you'll see, we don't need the help manual. So all we need is a couple vectors. So let's create 3 vectors, and then we'll bind them into a matrix. R1 is going to be a vector, and let's make it a character vector for a change. And what I want to say here is I'm going to say I am happy. Why am I happy? Because I'm sharing this knowledge with some awesome people. Thank you so much for taking this course. I hope you're learning a lot. Then a second vector is what a day. It's been a great day. And R3 is going to be just a vector of numbers. So let's say C1, 2, 3, right? So we have 3 vectors. Let's create them. And we want to put them into a matrix. The matrix is going to be called C. How do we put 3 vectors into a matrix if we want to bind them row by row? If we want them to be the rows? Well, we just say R1, we say rbind, and then we say R1, R2, and R3. And if we run this now, you'll see that here we go, we've got the matrix. Awesome. I'm happy, what a day, 1, 2, 3. And as you can see, the 1, 2, 3 are no longer numbers, they're characters, because you cannot mix different types inside a matrix, just like inside a vector. So the numbers were converted to characters automatically. Now let's do the same thing for cbind, right? We want, let's make some space. Let's start by creating vector C1. We'll just create 2 vectors. So there we go, C1, and C2 is going to be -1 to -5. All right, some negative numbers. Now matrix D is going to be cbind C1, C2, right? And now if I call D, you'll see I've got 1, 2, 3, 4, 5, -1, 2, 3. So I kind of merged those 2 vectors together into a matrix, like vertically like that. Okay, that brings us to the end of today's tutorial. And to quickly recap, we talked about three functions today. We talked about the matrix function, which bends a vector into a matrix, and this function, you won't be using it that much, but still it's important to know about it and know how it works. The rbind function, which binds vectors into a matrix row by row, and the cbind function, which binds vectors into a matrix column by column. So that's all for today. Hopefully you will have some time to practice these, and I highly encourage you to do so. So just create some of your own matrices. For instance, just one for each function will be enough. If you can do two for each function, that would be fantastic, just to make this knowledge sink in. And next time we will proceed with the next topic. And I look forward to seeing you in the next tutorial. Until then, happy coding.